All right, so that's question D. Just work, you will see it. Uh, if you worked with triangle APS and triangle APR, perfect, lovely. You're gonna be in the money there. Okay, then next up, we're gonna do the other one. This one I will do because there's something that I want to highlight here or point out. This is the one that I called example two. And what is rather interesting here is the fact that if you just rush and read and go to the proof, you realize that there is a problem with the top bottom story. The problem is that you cannot have, if you look at top bottom, you cannot have triangle ABED. You cannot. Although, yes, you can have triangle BCP or CBP, yes, but you can't have triangle ABED. Now, this will obviously frustrate you and you'll be like, but the methods are not working. No, guess what? The methods are working. The catch here is what I have always stressed, and I will re-emphasize again tonight. It's the fact that we've got to read. And in our reading, there's a very key statement there, which says that this line segment AB is actually equal to line segment CD. Of course, we are given that CD is also a tangent, okay? CD is a tangent, so we could, of course, think of tan chord and all that. I will get to the diagram, but it is quite important that we take note of this. And guess what? This is actually what is going to unlock everything. The moment we replace AB with CE, then we will actually note that triangle CDE does exist. And in this case, it is the top and the bottom approach that would work. Of course, if you tried a left right, you would have triangle ABC, but then the right hand side does not give you a triangle because you have four different letters. So left, right, top, bottom would not have worked at all. So it is the use of the information that is given that actually frees us and makes our methods or strategies relevant. So please beware of this. Okay, anyways, let's have fun. You know what I always suggest before you stress about similarity and all that. Look at the diagram, fill up all the information as it comes, that kind of a thing. Okay, I want you to remember. So it's important to read and see whether whatever is given in the statement is actually featured on the sketch. That is extremely important. So at this stage, we have already noted that AB, the chord AB, by the way, is equal to the chord CE. Those are actually chords, and we're going to apply the tan chord theorem here. Angle C1 must be equal to angle F1. But that is not the only situation. Angle C4 would also be equal to angle F1. And I'm using the principle or the fact that equal chords subtend equal angles. We spoke about this the other day. So I just look for angles that are subtended by these chords. So CE and AB. So as you can see, the chord AB actually subtends the angle C4 and the chord CE subtends the angle F1. Of course, there we've got tan chord. So we have already related three angles, which is great. Okay. Uh, then the next thing that we're gonna try and do is to also work with angles that are in the same segment, because I do notice that somehow we actually have two cyclic quads. Let me bring them to life for you. So there are 4 points here on the circumference. So there is a cyclic quad here, although it is incomplete, but it is there. So because of that, I will also then mark angle A the same way as angle F2, because these are definitely angles in the same segment. And then, of course, to also note, if you like, what else are we going to do now? If is this, if we draw chord AB, then angle B1, oops, angle B1 is also equal to angle C3. because they are also in the same segment. You see, if you don't see the chord, you must remember that an arc can also subtend an angle. So the arc AF is also subtending those two same angles, namely angle B1 and angle C3. So angle B1 is equal to angle C3. Remember, it's always nice to fill up this information so that when it comes to proving, or we just touch and go. It's all easy like that. Okay, I also see a lot of things like exterior angle of a triangle, and all those kind of things. But for now, let me try and just work with the information that we have extracted so far. So we know there's going to be triangle CDE. So let's just see what happens with triangle CDE. Here's triangle CDE. There's also going to be triangle. Where are you, triangle? BCP. Where is BCP? Here is B. There is C. There is P. Okay. Um, then we only have, oops, someone is not muted here. Let's help them. Okay. So we notice already here that, oops, only C1 and C4 are actually equal. So we need another sort of pair of angles that are equal. And I think we might maybe need to look at the second cyclic quad to be able to do that. So I will try and highlight the second cyclic quad in red, or I'll just draw that. And I want you to see how that actually becomes helpful. So there is a cyclic quad from point B to F to E and then C. And I noticed that the side FE is actually extended to form an exterior angle E1. And according to that principle or theorem that talks about the exterior angle of a cyclic quad, E1 must actually be equal to B2. Then I know I am done at this stage. I have enough information to actually prove that the two consent triangles are similar. So I will start my argument and say in triangle BCP and triangle CDE, that notification. Yes, that's important. Please, yeah, by now, guys, once I go mute for no reason, notify me immediately. So triangle BCP is actually similar to a triangle. Now watch. I had randomly written CDE. So surely this is not the correct order because it is not angle B and C that are equal. It is actually B2, which is equal to E2. So I must have E there. And then from E, we then said C4 is equal to C1. So then I must go to C. And then we said P is equal to D. So this is actually the correct sequence to use in naming the second triangle. Then I'll go angle, angle. All right, because indeed it is angle B2, which is E1, C4 is C1, and P2 is equal to angle D. So remember, order does matter in similarity. Now let's see, can we bring all this to life? As a result of similarity, we know the following will be true. BC over CE or EC is going to be equal to CP over CD. We know that much. But this is also going to be BP over ED, or maybe we should write that as ADE. Okay. Then what else? I also know, but let's write this down now. If you look at your at your question, your actual question, what you are supposed to prove, there's no CE featuring there. So we have to now say, but CE is actually equal to AB. This was freely given. So that's our justification, which means where we see a CE, we can actually write an AB. So therefore, my ratios will be the following. BC over AB. And then I know this is not needed because none of that appears in what I'm supposed to prove. But I do have a BP appearing and a DE appearing. Of course, in the actual proof, they don't have DE, they have ED, they don't have BC, they have CB, but we actually know those are exactly the same thing, right? So let's see. Are we done at this stage? No, it does appear that AB must be in the numerator, BC must be in the denominator. So we know actually these two are equivalent. So I'll just flip it around and say, okay, so AB over BC is actually DE over BP. Done. End of proof. That is correct. You are absolutely right to conclude that. Okay, so that was problem number 2 for the homework. You're in the money, well done. You struggled a bit, it's okay. You are starting this. Remember, practice makes perfect. So you just need to work a bit more, train your eyes to see these things. But I hope you have noted the strategy at this stage. And so all you need to do is learn to apply the strategy. Read the given information, see how it is featured on the sketch, try and relate the angles, and then when you have done that, go for your proofs. All right. Okay. Then we're gonna come to this one here, and then I had asked you to try this. Of course, it is also a homework question. Um, and I want to also highlight or say to you, if you omit the statement, this problem is definitely going to frustrate you. So you don't want to be frustrated. Read. I will keep on reiterating this because it is a lifesaver. So let's take note then that AB, which is this entire side of that triangle, is said to be equal to AC. And of course, this is not just given for vibes. The reason it's given is so that you may notice that ABC is an isosceles triangle, so the angle B must be equal to the angle C. Okay? But that is not the only bit of information given. Also given is the fact that PQ is equal to PR. So let's find PQ and highlight it. Here's your PQ and there's the PR. So again, another isosceles triangle. So Q2 is actually R1. Now let's look at the question. We are required to prove that BD over AC is actually equivalent to DR over AQ. So we know the strategy so far. We're going to check since they have not specified which triangles to work with, and there are quite a number of triangles on the sketch alone. I mean, there's quite a lot. Hey, I'm seeing how many? 1, 2, 3, 4, 5, 6. There's a lot. So let me just stop counting right there. So if I try the top bottom approach, I notice that I've got triangle BDR. If I look at the bottom, I notice that I've got a triangle ACQ. So my job now is to check, do these triangles actually exist? Okay, so anyways, we have already done applied the isosceles triangle thingy, so we can actually get rid of these because we need to clearly mark the triangles which we are working with on this similarity story. So I'm going to do that. So we remember that Q2 is actually equal to R1 and B is equal to C. So let's check. Does triangle BDR exist? Yes. Triangle BDR does exist. And do I have a side BD and a side DR? Indeed, I do. Does the triangle ACQ actually exist? There is A, there is C, there is Q, and it does appear this triangle truly exists. Now, look at what is happening already. Having just highlighted those two triangles, we can clearly see how this is going to help us. This is also going to help us. So we are done actually with this proof. So let us start there and say, well, looking at triangle BDR as well as triangle ACQ, and this is not necessarily the correct order. It is our proof that is going to outline the correct order to follow. So again, on the left-hand side, as I argue, I will have the angles from triangle BDR, and on the right-hand side, I'll have angles from triangle ACQ. So maybe let's color code this. So angle B is equal to angle C. My reason is very simple. Angles opposite equal sides. Since, well, if you like, you may want to tell the marker that you are aware of the fact that AB is equal to AC. Then the next one, I will go for angle R1, and I'm comparing this. So please be careful here, right? Angle R1 is in the green triangle, and I'm comparing this with angle Q2, which is in the yellow triangle. And the reason remains the same. Angles opposite equal sides. And to be clear, I will tell the marker that, hey, I'm aware of the fact that PQ is PR. That's why I conclude that angles opposite equal sides. Then what is the obvious? The obvious is that which was not mentioned in the above. So that is angle D1 in the green must be equal to angle A2 in the yellow. And our reason here is third angle of a triangle. Now, let's get the sequence correct. So, yes, indeed, I do have triangle BDR, but I will have to write it as triangle BRD. And this is actually similar to triangle CQA. Okay, and why? Because of angle, and since the two are similar, then the following must be true. BR over CQ must be equal to DR over AQ, and this must also be equal to BD over CA or AC, and just like that, you take this last two and they will give you exactly what you were required to prove. Done. So obviously I forgot, we must state the reason for these ratios. We have proven that the two triangles are similar. So similar triangles, same thing here. you would have said similar triangles. You don't just write that. Okay, reminder. Okay, similar triangles, and therefore, indeed, dr over aq is equal to bd over ac. End of proof. Done. Then I gave you this problem again to just emphasize the fact that, guys, you cannot do without your properties of quadrilaterals. In this case, you are given the quadrilateral called the parallelogram. But guess what? There are other quadrilaterals that may pop up. Okay, I mentioned the trapezium, I mentioned the rhombus, I mentioned the rectangle, square, and the kite. So it's important that you will know those properties of by heart. These are the quads. You basically learned that properly, I think, in grade 8 and 9. So you learned about sides, you learned about the diagonals, you learned about the angles and those kind of things. So those things will definitely help you. So if you do not know your properties of quadrilaterals, please, you are disadvantaging yourself. And I'm going to encourage you strongly so that please go on Pinterest, go on Google, search quadrilaterals and their properties. Get a nice poster, print it in A4 or A3. Make sure it is there until you know those properties of by heart. Okay, they will pop in, and you don't want to lose marks because of a shape, a two-dimensional shape which you learned 3 years ago. So 2 years. I think even in grade 10 you still learn about the quadrilaterals. So you don't really want to do that to yourself. Okay, so do it now while there is time. Okay, let's check. We have KLMN. We are told it is a parallelogram. And then we are also given that the angle K1 is equal to K3. The only nice thing that the examiner has done here is to indicate on the sketch that indeed K1 is equal to K2. But they have not put up the properties of what? Of a parallelogram. So what are those properties? Let's start with the angle properties. In a parallelogram, opposite angles are equal. You see, if you don't know that information about a parallelogram, you are doomed. And that's why I'm going to say again, go know that stuff. So angle N is equal to angle N, but also to note is the fact that angle M is actually equal to that entire angle K. We don't know whether we're going to use this or not, but it's important to take note of these things and embrace them. So that's far as the angles are concerned. Another thing that we know about a parallelogram is the fact that the opposite sides are equal and parallel. Hence the name parallelogram, because opposite sides are equal and parallel. So the side KL is actually parallel to the side MN, but it is also equal to that side. So I will mark that. Also to note is the fact that the side KN is actually parallel to the side LN, but also equal. And notice I use different markings. Okay, so that's what I've noted. Now, why is it important to note this? Because just like that, then you note that K3 is also equal to M1 because those angles are alternating. So you see, it is knowing your properties of the parallelogram that is unlocking all these other bits and pieces of information that were hidden from you. So please, very, very important to note that. But guess what? All of a sudden, it also becomes noteworthy that the angle M2, just M2 alone, alternates, okay? It is an alternating angle along with what? K1 and K2. So that's another little bit of information to be aware of. We don't know where it will take us, but it is noteworthy. All right. Um, what else? I think we have kind of done at least enough so far. There is another set of parallel lines given. This one was not even stated in the statement, but guess what? Here are the arrows to indicate that those two are parallel. So I should have also then adjusted my markings here, and that will be 3 because to say that there are now 3 sets of parallel lines here. Okay, great. Now, For this one, it is quite important then to note that the angle K1 and K2 corresponds with the angle S1. There is an F shape forming there. But not only that, I also note that the angle K2 actually alternates with T2. I have not even considered co-interior angles, but they are there. There are co-interior angles uh, like N and M, because of the parallel sides of the parallelogram. L and M are also co-interior, and furthermore, K1 and with K2 is co-interior with S2. I've not even included that, but just to show you, when you remember this, you get to know more, and that unlocks a whole lot of things for you. Okay, that's enough for now. Let us just check our first problem here. I will not go over all of them, by the way. In the interest of time, we need to do Pythec for today. But I mean, it's been all routine now, I think, because you can probably predict what I'm gonna say or do. So I'm just doing this so that in case you did not see all these relationships between the angles, you now see them, and you can actually go and do your own corrections. So let's wrap it up by just doing this first problem. Now, KL N, I'm just going for top bottom if you notice. So I'm just gonna check, do I actually have triangle KLN? And then as far as the bottom is concerned, do I have triangle KTM or KMT, whichever way you look at it? That's the question. Do these two exist? Then I'll go to my sketch and check, can I actually successfully highlight a triangle called KLM? And it looks like I can. And then do I have a side KL? Yes. Do I have a side what? I said I have KL. Do I have a side KN? I think I highlighted the wrong triangle, did I not? Yeah, I highlighted the wrong triangle. I went for M instead of L. KLN. So KLN, you see that triangle doesn't actually quite exist. However, you see, this is what is going to save you. Take note that Kn itself is actually equal to, watch this, Kn, I repeat, is actually equal to Lm, because these are opposite sides of a parallelogram. I will just write PAM for short. So do you see again how the property kicks in? So where we are seeing a Kn, we know that that Kn can actually be replaced by an Lm. So in other words, if I look at this triangle KLN, I can sort of now see triangle that. I can sort of see triangle KLM in this case, because really the side KN is the same as the side LN. I hope you see what I'm talking about. So we will come back to this. We do know that although the triangle does not exist, but one thing for sure, look, one thing for sure is we're gonna have a side KL, all right? But instead of of KN, we're gonna have LM, and then as a result, then we will have KM, okay? Um, the other one that I forgot to mention is about the diagonals. So we are not too stressed now because of that property. Okay, so instead of KLN, we actually said we're gonna look at KLM. Then let us also see then what is going to happen with KTM. Does KTM actually exist? I'm going to highlight KTM. Here is triangle KTM. There it is. Okay, this one exists. There's not much drama going on here, so we can gracefully embrace this one here. However, What we need to check now to be really sure that the triangle KLM is going to work. We are just doing top bottom for now before we change our minds and try left right. Okay, for us to be really sure whether a KLM is going to work, I'm going to do this. I'm going to check. Oops. KLM. Okay. Now, what am I noting in this scenario? I am noting the following, that, okay, triangle, actually the angle M1 is common. That's what I'm noting. The angle M1 is common. And then I actually don't seem to have another angle in KTM, which seems to be equal to another angle in the blue one, in KLM, in that bigger one, which is blue. I don't seem to actually have that. So I will probably then want to actually reconsider my top bottom approach at this stage. So I'm going to see, what if I do KLT, which is now, so this was top, bottom. It did give us triangles, but similarity is a bit of, it's too problematic at this stage. We don't want to think hard when, especially when we have filled up the information. Now I'm going to try left. Left hand side gives me triangle KLT. Now what does the right hand side give me? The right hand side gives me triangle KNM. Now let's quickly highlight these triangles and see if we have some money there. KLT. There we go. Now what's the next triangle? KNM. Let's highlight that triangle. KNM. It actually exists. Now I can also see that I'm in the money because by just looking at the information I've already indicated, I see that this angle is equal to that. So my first argument is actually good, but I also see that K3 is equal to K1. So I have two sets of angles that are good. So then here, because the process is quite smooth, I know that this is the way to work. So, and I love this question because it is bringing another lesson to you, that sometimes it may appear that both top, bottom, left, right exist, but you don't want to work hard. Like they say, work smart instead of working hard. So you want to really go with the easy way out. Okay. Although, of course, we may have maybe lost 2 minutes or so brainstorming, but our sweating was not in vain. So let's write now the argument. We know now that we've got triangle KLT and we've got triangle KNM. Now we will start KLT. Remember, that's the yellow one. So I will again keep the yellows on the left. So I will kickstart the process by saying the angle K1 is actually equal to the angle K3. And this was actually given. This was actually given. Then we will go for the yellow. The next angle is angle L. We know this one is equal to angle N, and this comes from our knowledge of what properties of the parallelogram. Okay, so we will say then opposite angles of a parallelogram, PAM. Once again, guys, if we get kicked out, you know what to do. You just log in again and then we resume. Okay. Finally, the only angle that we have not talked about is, take note, is the angle T1 and T2 combined. So I'm going to go for the three-letter system here and say angle LTK, because I don't want to write L1, T1 plus T2. And then this one, we know it will have to be, doesn't have much of a choice, isn't it? It will have to be equal to angle M2. And our reason here, third angle of a triangle. Therefore, now order must be observed. Triangle KLT indeed is similar to triangle what? KNM. Here, coincidentally, I got the order correct. you know what to do from here. I will stop there. But please, I repeat, it is very important that you will know the properties of your quadrilaterals. I will go over those tomorrow actually, and show you how important they are in case you are not sure, but I'll bring that to life. Okay, cool. Guys, today we're going to talk about Pythag. Let's get into the discussion.